Hi, welcome. We're gonna be looking at some basics of linear equations and functions in the next couple of videos, and specifically this one is focused on helping you be able to graph lines. We're going to start off with a specific form of the linear equation, which is called the slope-intercept form, which the name is very telling of a linear equation because when we look at it, we can tell a couple of things. Number one, we can tell what the slope is, and the slope we generally write as m, right? And the y-intercept we write as b. So m is representative of our slope, and the way we can find it is it's always the number in front of x. And the y-intercept we write as 0b because the y-intercept is always located where x is equal to 0. So on my graph here, where x is equal to 0, the b would be the second number I would either go up or down to find. So when an equation is solved for y, meaning y is completely by itself over on the left-hand side, it is in this particular form, the slope-intercept form, and we can discern those two things, which as we'll see, are helpful for us to graph. Now, any line or any graph that we do is really a display of solutions for that particular equation. When we say solutions, those are numbers that make my statement of equality true. Right? In an equation, we're always looking for solutions. Well, in a two-variable equation like we have here, and by the way, we could also express this as f of x equaling 2x plus 1. That's just telling me this particular relationship is a function relationship, or we can have y there. Either way, it's the same thing, same idea, just different symbolism. But we're looking for pairs, x's and y's, that match up to give me something that's equal, where the left-hand side is equal to the right-hand side. And so with a two-variable equation, generally there are an infinite number of solutions. We just have to find a couple of them. For lines specifically, we have to find at least two solutions. So what that means is I can just pick some values for x, especially when it's solved for y like this. So let's say I'll plug in -2, 0, and +2. And I'm going to plug these in and get a y outcome, right, that are paired up with these x's. Now, why did I pick these numbers? No particular reason. I picked them because there's a negative, there's a positive, and they kind of spread out between -2 and +2. You could even go a little bit further. I like my points to generally kind of be spread out. So you could even pick like -5, 0, and +5. That spreads them out a little bit more. The further your points are spread, the clearer your line will be. When they're really close together, it's hard to really connect those at the correct angle, and that type of thing is very unexact. So plugging -2 in for x then, and rewriting this, whenever you substitute into a formula, always use parentheses. This especially becomes important with x squared, as we'll see down the road here. But this gives me -4 plus 1, which is -3. So -2 is paired up with -3. I always like to pick 0 because 0 does kind of a elimination thing. Anything times 0 is 0, so that's 0 plus 1, which is 1, which we already knew actually because of 1 being that plus 1 there. That told me it was the y-intercept. So you can see why the number, since it always is paired up with 0, when I plug the 0 in for x, it'll always eliminate the first term, and we're just left with that number that was by itself. That's why that's always the y-intercept. And then we'll plug in +2. So 2 times +2 plus 1, that's 4 plus 1, which is 5. Okay, so I have 3 points. I'm going to plot those out. -2 and -3 puts me down here. 0 and 1 puts me on the y-axis there, and then 2, positive 5 puts me up here. If your points are correct and they are solutions, they should line up in a straight line for a linear equation. So now I'm going to use a straight edge, connect those points, and always put arrows. Arrows are important because it tells us this goes on and on and on for infinity. So there you have it. That is our display of all the possible solutions. For example, on some of these, of course, they'll be fractional, but here we can see an intersection here with 1 and 3. So that tells me 1, 3 is probably a solution, unless I, graphed it a little incorrectly. But you plug in 1 for x, so y equal to 2 times 1 plus 1, we get 2 times 1 is 2, and 2 plus 1 is 3. So this is literally a display of every possible solution of that particular equation. And what we're looking at is the pattern that develops with that. All right. So looking at this line, let's talk about that slope and the y-intercept. The slope is defined as change of y over change of x. This delta symbol, the little triangle, is the Greek delta symbol. And what it means is change. And for change in y, that means going up or down. And change in x means going left or right. So how does 2 display that? Well, looking at 2, if we think of 2 as being over 1, any whole number we can always put over 1, and you should. Not because the 1 is the y-intercept, but just because 2 divided by 1 is 2. And so we're looking at 2, but we're looking at it in a dynamic way as it relates to x. So this tells me with a positive 2 over positive 1 that I'm going to rise 2 and I'm going to move to the right 1. So you can see that the slope represents movement, it represents change. And the idea here is, and you may have heard rise over run, that's another way of thinking about it. Running, is kind of, we run from left to right, we rise, we go up or down. Right, down would be kind of a negative rise. But regardless, this is describing or attempting to describe how steep the line is. So in other words, with the slope of 2, we're saying that for every 1 that we move to the right, we've risen 2 units. Now, if we look at a starting point on the line, we can see the slope at work. The slope, with a rise of 2, would put us up at 3, and then to the move to the right 1, that would put us at another point that's on my line. Again, doing that a second time. If we rise 2, we're up to 5, and then to the right 1, that puts us at 2, 5. All of these are points on the line, right? So the red that I'm drawing is just showing that movement. It's not part of the graph. To go down 2, that would take me to -1. And I can do that as long as I also move to the left 1. Let's go back to the fraction that we had. Positive 2 divided by positive 1, as you see here in our fraction. Positive 2 divided by positive 1 is 2. But there's another way to get 2, and that's by going down 2 and to the left 1. -2 divided by -1 is also positive 2. These are both positive 2. Just different ways of expressing it. 2 negatives, whenever we divide by the same sign, 2 positives or 2 negatives, we get a positive outcome. And I can continue finding more points on the line. These also work for, since we started at a whole number, right, at 0, 1, we're ending up at whole numbers. But remember, there's all the fractions in between as well. But it's a little bit harder to use slope with fractions. But starting with any point on the line, I can either go down or up 2, so down 2 to the left 1, and we're at another point that's on the line. Again, the line is a display of every possible thing. So the slope in the y-intercept is another way that we can graph our equations. All right, so let's take another example here where it's in slope-intercept form. We have y by itself, and so we can discern what the slope is. The slope is -3, so I'm going to put that -3/1. And my slope is at, or I'm sorry, not my slope, my y-intercept is at 0, -2. Now, why is it -2? We have a subtraction of 2, and if you remember back to the general form, it's y equals mx plus 2, or plus b, sorry. That's the general form, and b, when it's in this form, is the y-intercept. Well, with a subtraction here, remember, we can express every subtraction as an addition, so it looks like the original here, and that helps us to discern what b is. I can change every subtraction to an addition as long as I change the sign of the number that follows it. So I make that +2 into a -2. That tells me that b is actually -2. So whenever we see a subtraction, we know that that number, we want to interpret it as being negative. Okay. So, given these two things, 0, -2, I know is a point on my line. So I'm going to put that here. And now we're going to use the slope. -3 over +1. Since my slope is negative, -3, we want to think of that as -3 over 1, because negative divided by a positive is negative. We can also think of it as +3 over -1, right? That also gives me -3. And both of these will get us to other points that are also on the line. So from -2, if I go up 3, 1, 2, 3, that puts me in a +1. And then I would move to the right one. And actually, I just made a mistake there. I'm going to erase that because I went in the wrong direction. I went up 3. So I didn't want to go to the right one. And if I go up 3, I want to move to the left one. So we're going to correct that, and put it in its proper spot. I can also go down 3, 1, 2, 3. Put that in red. So that's down 3, as long as I also move to the right one. And see why it's important to really have those written out. And you should see your points lining up. If you're going in several different ways, make sure that your points are lining up. Otherwise, something's probably off there. Right? Using a straight edge, I'm going to go ahead and write that in there, connecting my points. Okay, that was terrible. So do a better job when you do it. That's why it's important to use a straight edge. And put arrows, because those arrows mean that we continue to follow this same pattern for infinity. That was really terrible. So terrible, I'm going to move to the next slide here. All right, one more fraction. As my slope. So m is equal to -1/2. Now, with every fraction, and this is true with our whole numbers as well, I'm going to rewrite this a little bit. When a fraction is negative, -1/2, that means it's either -1 over +2 or +1 over -2. With a negative fraction, they both aren't negative. The negative either goes with the top, and that's generally where we put it, or it could also go with the bottom number. But those yield -1/2. When the signs are different in a division and a multiplication, we get a negative outcome. And then the y-intercept is 0, 3. So 0 for x, and then up 3 units. Using my slope of 1/2, I'm going to start with this one. I can move down 1 and to the right 2. If I move down 1, I need to move to the right 2, put a point, but I can also go in the other direction, up 1, right, following this one, and I can do that as long as I move back 2. +1, -2. And there we have our line. Using our straight edge, and draw that in there. And put some arrows on either end to show that it's going on for eternity. Or infinity is probably a better way to express that. All right. Now, if I'm given an equation, or a graph, I can find, sometimes, depending on the graph, but it's possible for me to actually find the slope-intercept form. Now, of course, one of the things that we really have to have in order to be able to do this, to look at a graph and know that it's, or to come up with this equation, is to know what the y-intercept is. And looking at this, we can see that it's crossing at a whole number. If it was crossing in between the -1 and -2, we wouldn't really know where that, so in other words, if the y-intercept was a fraction, we wouldn't really be able to do this. But since it's crossing at a whole number, I know that my b is -2. And then from this, I can find another place where I know I have numbers, or whole numbers, right? So it looks like it's passing through here at 2 for x, 2 for y. There's also this one here where it's 1 for x and 0 for y. Anywhere I go, really, I can figure out what the slope is from that. So I'm going to actually do the ones that aren't right exactly next to each other. Okay. So I'm going to just kind of ignore this one, just to show you that it could be for any points that are actual points on the line. I can see that from going this point to this point, there was a rise of 1, 2, 3, 4. There was a rise of 4 units. And then once I rose to get to the other point, I also would have needed to go to the right 2 units. All right, so again, slope is change of y over change of x. In this case, my change in y, my change in height, was 4 units, and my change in x was 2 units. And 4 divided by 2 is +2. So in this case, I see that my slope is 2. Now, this would have happened for any point. So I'm just going to erase this. Let's take a couple of other points. Let's go from here up to here. Or actually, let's go from here to here. This would be a rise of 2, and to the right 1. So that's 2 over 1. +2 over +1, which also is 2. Right? And this would have been another +4, and to the right +2. And in fact, we could go from way back here. This was, if I go from here up to this point, I've risen 1, 2, 3, 4, 5, 6, 7, 8 units. So +8. And guess what this would be? This is +4. I'm going from here, and I'm going to the right. 1, 2, 3, 4. So 8 divided by 4, +8 over +4. Again, 2. All of these going from one point on the line to another point tell me that my slope is 2. Plugging that into my slope-intercept form of the linear equation, we see that the equation for this line is y equals 2x plus 1. All right, another one here. I can see that my Y-intercept is at -2. Is this the same? It is the same line. Okay, well, I'm not going to go and redo that because it's actually the exact same line, I believe. 0 and 1. Yep, it's the same line. Sorry about that. I was meant to get 2 different lines in there. Okay, so here's another sort of way that linear equations are usually made to model certain situations where there's a starting point and then there's a consistent rate of change, which is, of course, you guys know, is our slope. So in a case, this is just an example of where we might see a linear pattern like this. Emily's running a coffee stand. Her cost of labor is $90 a day, and her cost per cup is $1.30. Write a cost equation for each day. And we would need to specify that. Write a cost equation for her business for daily costs. All right, so her labor is $90 for each day. That's kind of fixed, right? She's going to pay whoever's working $90. So for a cost equation, and I'm going to put C as just her costs. What are her costs going to be? We know that each day there's going to be a fixed cost of $90. But then her non-fixed cost is really based on how many coffees she sells, because each cup, and she's just figuring all the all the costs, the milk, the syrups, the coffee, the this, the that, the whatever, is all comes out to be about $1.30 per cup. So this is the part that's going to vary each day, right? Depending on how many cups she sells, that she's going to have a certain cost that goes with that, the products that she needs to buy to make the coffee. So this is the non-fixed part, right? So this is the variable, and I'm going to put C as coffee, or I'm sorry, cost. So I'm just going to use X. So X is going to be the number of cups sold, and you can use whatever variables you want, right? The C is kind of standing in for my Y, because the cost is going to vary based on the number of cups are sold. And to the cost of $90 for the labor, we're going to add $1.3 times X, the number of cups sold. All right. So, in other words, there is going to be a direct linear relationship with our costs. This is our fixed, which is our Y-intercept. So this is like my B, right? And then this is my rate of change. So this is my M. So notice that I have them written maybe in a different order, but both orders would be the same equation, right? Whether I write it as 1.30 times X plus 90 or the other way around, it's the same equation. My slope is always the number in front of X, not necessarily the number that's written first, right? Here I have the 90 written first, but it doesn't have the X with it, so it's still the Y-intercept. So I hope that begins to help you through the first part of this assignment, where we focus mostly on graphing and just lines and their slopes.